Today we're going to learn a new method of factoring besides the greatest common factor, factoring trinomials, and the factoring of difference to squares, and it's called factor by grouping. Now typically factoring by grouping is used for third degree polynomials. The last couple of examples we've worked on were second degree polynomials because the highest degree is a 2. The highest exponent is a 2. So let's say we had something like x to the third plus 2x squared plus 9x plus 18. This is a third degree polynomial because the highest exponent is a 3. Now typically we would look for the GCF first, and in this case x to the third, x squared, x, no x's. So x is not a common factor. So let's look for a numerical GCF. 18, 9, so far so good. 2, nope. There's no GCF here. So we need another method because this is not a trinomial. There's 4 terms, not 3. And it's not a difference to squares. Not only is it not a difference, there aren't 2 things. So we need another method, and that's where factoring by grouping comes in. So what you do is group 2 terms together and factor them with the GCF independently. So the GCF between x to the third and 2x squared is x squared, which leaves us with, we'll divide that, gives you x. 2x squared divided by x squared is positive 2. The GCF of 9x and 18 is 9, positive 9, which leaves us with an x plus 2. So now, you can see there's something in common here. It's a common binomial factor. We're used to common monomial factors. So what I'm going to do, I'm going to provide a parallel example which helps you visualize the common factor. If I have x squared times a plus 9 times a, I know that my GCF is a, which leaves me with a times x squared plus 9. So if I said, let's let a equal x plus 2. That means we have x squared times a plus 9 times a. After we factor with the GCF, a times x squared plus 9. But a is x plus 2. That's what the equal sign means. A is x plus 2. So not a, x plus 2. And that's factored completely. This can't be factored. This can't be factored. But if this were a negative, this would still be factorable. That would be the difference to squares. This is the sum of 2 squares. Much different than a difference of 2 squares. Let me give you an intermediate example of factoring by grouping. Let's say we had 2x to the third minus 3x squared plus 8x minus 12. So again, I can't factor with a GCF because of that 3 there. If I had a GCF, I would pull that out. That's divisible by 2, that's divisible by 2, but this one's not. Otherwise, I would factor out a 2, but I can't. So let's factor by grouping right away because there are 4 terms. The greatest common factor of 2x to the third minus 3x squared is x squared, leaving us with 2x minus 3. Now this is going to help because now I see what this is my common binomial factor. So I'm going to have a 2x minus 3 over here, and that should really help us find the GCF over there. So the GCF of 8x and negative 12, positive 4. Divide both of these terms by 4, which gives you 2x minus 3. What do you know? There it is. Common binomial factor. So we have a 2x minus 3 in common. Eventually, you'll be able to skip this let statement, but we're going to say let a equal 2x minus 3. And this will really help us visualize the common binomial factor. So we have x squared times a plus 4 times a. GCF of a times x squared plus 4. But what was a? 2x minus 3. 2x minus 3 times x squared plus 4. Common error here. Don't forget to keep this term in parentheses because this is saying negative 3 times that. We want to say all of it times x squared plus 4. And this is factored completely because there's no GCF of 2x minus 3. There's no GCF of x squared plus 4. And x squared plus 4 is not the difference of two squares. And that's factoring by grouping.